Hi and welcome to another C++ programming tutorial from Someone9031, and in this tutorial I'm going to be teaching you guys about the C++ preprocessor as well as preprocessor directives. So when you create a program in C++, the actual C++ code that you write is not actually readable by the computer. The computer does not understand it. The only thing that the computer understands is something known as machine code, which is basically ones and zeros. And the machine code is what the computer understands and knows what to handle. So when you write a C++ program, to make it run on a computer, you first have to do something known as building or compiling. So when you build your program, the first thing that happens is something known as preprocessing. And preprocessing is something that happens before the code is actually compiled by the compiler. And the preprocessing is done by a program known as a preprocessor. And the preprocessor checks over your C++ code and it looks for any preprocessor directives, and it changes the code, your C++ code, based on what the preprocessor directives say. And then after the preprocessor directive is done, the changed code is put into a .i file, or an intermediate file. And the .i file is the file that is actually passed into the compiler to be turned into machine code. So the preprocessor directives will all be gone, but the code will be changed based on what they do. So yeah, let's get started. Every preprocessor directive starts with a pound symbol, and it's this symbol right here. You might call it a number symbol or a hash symbol or a sharp symbol, but in C++ it's called a pound. And the most basic and most commonly used preprocessor directive is the pound include directive. So the pound include directive is what you use to include header files. And header files are basically code files that contain like centralized code that's used very often, so they are included in all the files. So for example, IOStream, the IOStream file is the input and output stream. It handles basic console input and output. So by creating the IOStream header file, that means that we don't have to write out the input and output code every time. We can just include that particular header file every time we use a program that does input and output. So there are two versions of the pound include statement. There's the version where the header file is included within angle brackets, or these greater than and less than signs. And that means the header file between the angle brackets is a C++ standard header file, and the preprocessor will look within the folder of standard include header files, that are included with C++. And that's where it will look to find that particular header file. And the one we've been using very often is the IOStream header file, which handles input and output. So this is within angle brackets because IOStream is a standard C++ library. It's a standard C++ header file. So it's within this standard include file. And the other version is a pound include directive with double quotes, which means that C++ will look in the local directory. It will look for that particular header file within the same folder or directory as the source file, or this main.cpp file. So we are not using that yet because we have not actually gone into making our own header files. So for now it's just the ones in angle brackets. We're just using the ones that are included with C++. The second most commonly used preprocessor directive is the pound define directive, and that defines constants, which are basically like constant variables. So to use this, right after pound define, you put a space, and then you put the identifier, or the name of your constant. So I'm going to call mine num for number, and after that another space, and then you put the value of that constant. So we're going to make it 12, but you can really make it anything. You can make like 1368, or you can make it a string that says hello. You can basically make it anything you want, but we'll make it 12. So now, if we write out a program, we can now create an int num, and then we can put equals num. And basically, when the preprocessor goes through this code, it'll see this. Well, first it will see this pound include directive, and it will include the IOStream file from the standard include folder. And then it will see this pound define directive for num. So after that, it will go through your entire code file, and every time it sees num, or whatever your particular identifier is, your constant identifier, it will replace that identifier with the value of that identifier. And you should know that that is not type safe. So if we change this instead to hello, it would still do a replacement. But Visual C++ is a very smart compiler, and it has seen right now that you cannot convert a character string into an int, so that doesn't work. But on most compilers, or if you're just writing this out within like Notepad or anything, this won't work. Like, it won't detect that as an error. But then when you build it, it'll be like you can't convert a string into a number. So that's basically why you don't really use preprocessor directives anymore. There's many better options like constant values, like constant variables. The only reason why preprocessor directives are still within the C++ language is because C++ needs to maintain compatibility with the C programming language, which is still a very popular and commonly used language. So that's the only reason why C++ still has preprocessor directives. And the fact that we have these header files. That's the only one that we normally would use. You can also use the pound define directive to make something called a macro. And a macro is basically a function. So a macro, let's just call it double. So we have a double macro that will double an integer that is passed into it. So just get rid of this for now. So to write on the macro, you put name of the macro, and then you make parentheses, and then you put the argument that it will take. So in this case, it will take an argument x, and then it will do x times 2. So there is our macro, x times double, it will take x, and it will do x times 2. Now you might be asking, why do we need this parenthesis right here? We need that because, well, if we passed in, like, say num, okay, if we passed in 10, so double num, you basically have to think about after, because macros also have text replacement. It's basically a text replacement. So you have to think what it's actually doing. So it's actually doing num times 2. Okay, so that works, but say we had double and we passed in 5 plus 7. Now this happens to be a problem. If we didn't have these parentheses around this x, double will turn, when it does the text replacement, it will do this. It will do 5 plus 7 times 2. And because it will do multiplication first, it will actually be somewhat like this. So it will do 7 times 2 first, then plus 5. And that's not what we want. We want 5 plus 7, then times 2. So that's why we need parentheses around this, so that every variable will be contained. So the final preprocessor directive is basically a comparison directive, And let's just get rid of this code for now. So we should have pound define. Let's define x as 0, and then now pound if, and then x. So with a preprocessor if, it's different from a normal if statement. With a normal if statement, if the value does not equal true, then it will just skip past the if statement and execute the next line. With a preprocessor if the value does not amount to true, then the whole code between the if and the end if will not be included. Like, the code will just be taken out and not put into the the intermediate code file that is passed to the compiler. So if x, if you just put the name of a constant, that checks if that constant equals 0. So if x does not equal 0, then the code after here will be executed, or will be included, sorry. If x does equal 0, all this code will just be chucked out. So if x doesn't equal 0, then define y as 10. And then every if statement needs an end if because it needs to know when the if statement ends. And as you can see, all this code between here is now grayed out, and that's because with this particular compiler, it will actually check preprocessor statements, and it now sees that x does equal 0, so all the grayed out code will just be thrown away. Now you can also have else if preprocessor statements, and that's el if. So else if x does equal 0, then define y as 5. And then we could have pound else. So for everything else, I don't know why it would be anything else, but if it was for anything else, we would do pound define y as 0. And then after all of this, we need end if. And there's one more thing. It is the if defined. So we can have pound if defined, and that checks if the following value has been defined, the following constant. So if defined y, so it checks if y has been defined, and if it has, it will include the following code. And you can also have if def, and it's the exact same thing. Or you can have if and def to include the following code only if the following thing is not defined. So yeah, there's also one more directive that's often associated with preprocessor directives, but really isn't a preprocessor directive, and it is type def. And type def basically creates a alias for the for a variable type. So we can type def int, and we can make it int. So that basically goes and you can now use int instead of this int. So that's what type def does. It's not really a preprocessor directive. You can tell because it doesn't have a pound in front of it, but many people associate it with preprocessor directives. And there are also many preprocessor directives that are now included within C++, many pound-defined constants. So let's just use some of them. So we have main, and then we can see out current code line, and then we can use the underscore underscore line and then underscore underscore, and that is a pound defined constant that is standard with C++, and it prints out the current line, the current code of the current line of code. And then we can have cout underscore file, and we can have current time underscore time. So these these predefined constants are sort of dependent on your current system, what computer you run, what operating system you run, and what compiler you're running. So I'm not really going to go over all of them because it really depends on what compiler you're running, because different compilers have different included constants. So I'm not actually going to get really into that. So yeah, this is the end of the tutorial. If you like this video, please subscribe, rate. If you have any feedback, comments, or questions, any questions about this or any other C++ topic, please feel free to leave a comment below or message me on YouTube. And thanks for watching.